Hello everyone, my name is Shalini, student of SVCE. In this video, I'll be talking about contiguous memory allocation. Contiguous memory allocation is a method used by the operating system to manage memory. It involves the allocation of a single block of memory to a process. Here we have the contents. Introduction, how contiguous memory allocation works, contiguous memory allocation in operating systems, examples of contiguous memory allocation, advantages of contiguous memory allocation, disadvantages of contiguous memory allocation, accessing a file in contiguous memory, contiguous allocation as an application of dynamic storage allocation, fragmentation in contiguous memory allocation, significance of external fragmentation, techniques to reduce fragmentation, comparison with other memory allocation techniques, modified contiguous allocation scheme, conclusion. Starting with the introduction, contiguous allocation requires that each file occupy a set of contiguous blocks on the disk. Disk addresses define a linear ordering on the disk. With this ordering, assuming that only one job is accessing the disk. Accessing block B plus 1 after block B normally requires no head movement. When head movement is needed from the last sector of one cylinder to the first sector of the next cylinder, the head need to only move from one track to the next. Thus, the number of disk seeks required for accessing contiguously allocated files is minimal, as a seek time when a seek is finally needed. The IBM VMCMS operating system uses contiguous allocation because it provides such good performance. Contiguous allocation of a file is defined by the disk address and length in block units of the first block if the file is n blocks long and starts at location 17. Then it occupies blocks B, B plus 1, B plus 2 till 17 plus n minus 1. How contiguous memory allocation works. Memory block. A process is allocated a contiguous block of memory from the available space. Addressing. Each byte in the block is assigned a unique address for data retrieval. Execution. The process executes utilizing the allocated memory for its functions. Contiguous memory allocation in operating systems. Windows uses contiguous memory allocation for executable files and dynamic libraries. Linux employs contiguous memory allocation for process memory management. Mac OS utilizes contiguous memory allocation for application memory allocation. Next, we have examples of contiguous memory allocation. 512 KB for embedded systems, 2 MB for real-time applications, 4 GB for database management. Advantages of contiguous memory allocation. Simplicity. It's relatively straightforward and makes memory management more efficient. Sequential access enables faster read and write operations, especially for large data sets. Fragmentation, it minimizes external fragmentation, leading to optimal memory usage. Next, we have disadvantages of contiguous memory allocation. Memory wastage, it can lead to internal fragmentation because of fixed block sizes. Size limitations, difficulty in allocating large blocks can be a limitation. Dynamic data structures makes it challenging to manage dynamic memory requirements. Next, we have accessing a file in contiguous memory. Accessing a file that has been allocated contiguously is easy. For sequential access, the file system remembers the disk address of the last block referenced and when necessary reads the next block. For direct access to block I of a file that starts at block B, we can immediately access block B plus I. Thus, both sequential and direct access can be supported by contiguous allocation. The directory entry for each file indicates the address of the starting block and the length of the area allocated for this file, which is shown in the figure 11.5. By the by, we have contiguous allocation as an example of dynamic storage allocation. Contiguous allocation has some problems. However, one difficulty is finding space for a new file. The system chosen to manage free space determines how this task is accomplished. Any management system can be used, but some are slower than others. The contiguous allocation problem can be seen as a particular application of the general dynamic storage allocation problem, which involves how to satisfy a request of size 11 from a list of free ols. First fit and best fit are the most common strategies used to select a free OL from the set of available OLs. Simulations have shown that both first fit and best fit are more efficient than worst fit in terms of both time and storage utilization. Neither first fit nor best fit is clearly best in terms of storage utilization, but first fit is generally faster. Next, we have fragmentation in contiguous memory allocation. Internal fragmentation occurs when memory is assigned in fixed sized blocks, leading to unused interior space. External fragmentation results from the scattering of free memory space in smaller, non-contiguous areas. Next, we have the significance of external fragmentation. All these algorithms suffer from the problem of external fragmentation. As files are allocated and deleted, the free disk space is broken into little pieces. External fragmentation exists whenever free space is broken into chunks. It becomes a problem when the largest contiguous chunk is insufficient for a request. Storage is fragmented into a number of holes, no one of which is large enough to store the data. Depending on the total amount of disk storage and the average file size, external fragmentation may be a minor or a major problem. Next, we have the techniques to reduce fragmentation. Compaction. Some older PC systems used contiguous allocation on floppy disk to prevent a loss of significant amounts of disk space to external fragmentation. The user had to run a repacking routine that copied the entire file system onto another floppy disk or onto a tape. The original floppy disk was then freed completely, creating one large contiguous free space. The routine then copied the files back onto the floppy disk by allocating contiguous space from this one large hole. This scheme effectively compacts all free space into one contiguous space, solving the fragmentation problem. Best fit allocation, assigning the smallest block that meets the process's memory requirement. Buddy system, dividing available memory into blocks to satisfy a request exactly. Comparison with other memory allocation techniques. Contiguous, segmented, paged. Contiguous allocates large chunks. Segmented divides memory into segments. Paged divides memory into fixed sized pages. Contiguous has minimal overhead. Segmented supports variable size. Paged as flexible memory usage. By the by, we have modified contiguous allocation scheme. Even if the total amount of space needed for a file is known in advance, pre-allocation may be inefficient. A file that will grow slowly over a long period, months or years, must be allocated enough space for its final size. Even though much of that space will be unused for a long time, the file therefore has a large amount of internal fragmentation. To minimize these drawbacks, some operating systems use a modified contiguous allocation scheme. Here, a contiguous chunk of space is allocated initially, and then, if that amount proves not to be large enough, another chunk of contiguous space known as an extent is added. The location of a file's blocks is then recorded as a location and a block count plus a link to the first block of the next extent. On some systems, the owner of the file can set the extent size, but this setting results in inefficiencies if the owner is incorrect. Internal fragmentation can still be a problem if the extents are too large, and external fragmentation can become a problem as extents of varying sizes are allocated and deallocated. The commercial Veritas file system uses extents to optimize performance. It is a high performance replacement for the standard Unix UFS. Concluding the presentation by summarizing the prior slides, in conclusion, contiguous memory allocation offers efficient memory management by allocating contiguous blocks of memory to processes. It presents trade-offs between memory management complexities and speed. However, it has limitations such as fragmentation and inability to support dynamic memory allocation. Despite these drawbacks, it remains a widely used method due to its simplicity and efficiency for certain types of applications. Thank you.